Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek and I am Assistant Professor at Government Engineering College, Bilaspur, Chhattisgarh. And in this video lecture series, I am dealing with Signal and System subject. We are in the lecture number 4, module number 5. Overall, we are in the 35th lecture. So, till now we have completed in this module Laplace transform, inverse Laplace transform, and Laplace transform for some standard signals, and then we have seen some of the properties of Laplace transform. Today I will try to finish up this Laplace transform chapter, and let's move on for this lecture. So let's get started. See, we have seen many properties. We'll see some more properties like multiplication by t. Okay, so we'll see multiplication by t. Okay, what will happen when f of t is multiplied by t? We have seen when f of t is multiplied by exponential signal, what was happening. We have seen time shifting property also. Now we'll see what will happen by multiplication of t, and what will be the effect on the ROC also. That is also more important. So we'll see f of t is there, and if we take Laplace transform, we'll get f of s. Okay, fine. And then if we are multiplying t into f of t, we will get, and we will take Laplace transform, we will get minus df by ds. This you need to remember. Okay, so this is the property which is used in many questions also. So this property you need to remember: multiplication by t equal to t into f of t is equal to minus df by ds. Or inversely, you can also tell like that d of df by ds, if you want df by ds, and if you take inverse Laplace transform, you will get minus t into f of t. Okay, so like this inverse means inverse also you can take. Okay, so see, we'll see one question like, see, u of t was there, u of t is there, its Laplace transform will be 1 by s. Okay, now t into u of t will be there, then what will be happen? Minus df by ds will come na. Okay, minus df by ds, so minus d by ds we can do of 1 by s, which what will get, minus here minus 1 by square, so plus 1 by square, 1 by s square. This is t of u of t Laplace transform. Okay, Laplace transform, this is important. Okay, now if you'll do t square into u of t, what you'll get? You'll get d by ds minus d by ds of 1 by s square. You'll get minus and minus plus 2 by s of q. So t square u of t Laplace transform will be 2 by s cube. So somewhere you can see, normally u of t is 1 by s, t of u of t into u of t is 1 by s square, t square into u of t 2 by s cube, and so on. So if we'll go for moreover nth power of t into u of t, what you will get? Laplace one, because this is important, that's why we are seeing it. So we'll get n factorial and s to the power n plus 1 will come. Okay, here you can apply to this. T square means 2 factorial is there, and in downside s to the power 2 plus 1, that is 3. Okay, so this expression will come, this expression is the final expression for t to the power n into u of t. Okay, so we can apply this formula in another signal also, like, see, you have been given your signal e to the power minus at u of t was there. So what will be the Laplace transform? What will be the Laplace transform? Will be 1 by s plus a will be there. Okay, now if we multiply t into e to the power at u of t, what Laplace transform will get? Laplace transform 1 by uh, minus d by ds will come, s plus a will come, and this will lead to minus minus plus 1 by s plus a square, s plus a square, like this. So if we'll go for t to the power n e to the power minus a t u of t, what Laplace transform will get? We'll get n factorial by s plus a will be there, n plus 1 will be there. Okay, so this expression is also worth importance, so you should understand by this. And see, nothing is changed, means ROC is not affected when we will do multiplication by t. So here in green color I will write here multiplication, okay, multiplication by t does not affect ROC. Whatever your f of t, Laplace transform f of s, ROC will be there. That same ROC will be there when t is multiplied also. Nothing will happen. So this you should remember. Okay, this you should remember, because its ROC is not changed. That's why questions can be asked from this side also. So we'll do some questions and we'll try to understand how we can do. See, I'll give you four questions and I'll ask you which of the following system is stable or unstable. You need to answer me, or here. See, if I'll ask you t to the power n, e to the power minus at u of t will be there. Okay, minus t to the power n, e to the power minus at u of minus t will be there. Okay, minus t to the power n, e to the power at u of minus t will be there, and t to the power n, e to the power at u of t will be there. These four options are there. Now you need to check that which of the impulse response is stable, which is of the impulse response is stable. So we will check here. This is nothing but n factorial by s plus a to the power n plus 1 will be there, and ROC will be C, ROC will be uh, s plus a, real part of s plus a is greater than 0 because u of t is there. So real part of s is greater than minus a. Real part of s is greater than minus a means minus a will be here, then its ROC will be like this. It will include the j omega axis though. So this system will be definitely will be stable. This will be there. See, this is the same system, n factorial by s plus a to the power n plus 1, but this ROC will be real part of s is less than minus a. So will it be stable? So you'll tell no sir, this is not stable system. So you'll tell it is not a stable system. Okay, and then if you'll see this type of system, this is your n factorial by s minus a will be there, n plus 1 will be there. Okay, and okay, fine. And here real part of s minus a will be less than 0. So real part of s is less than a. So it is, if a is there, so its ROC will be here. It will include j omega axis, so it is stable. And this, if you'll see, this it will come this equation n factorial s minus a will be there, n plus 1, and this is real part of s will be greater than a, and this ROC will be here in the right hand side of a, and this system, this will not be stable because it won't include j omega axis. So now you can understand that after seeing the impulse response, how we can see the system is stable or not, this system. Okay, so we'll try to solve some of the questions. Let's see some question. One question is there. Let's suppose this question is there. Okay, this question, and you have been asked, it is just a revision recap of your understanding, what you have understood till now. This is 2 4 7 will be there. Okay, and this value is exactly 6 value now. Okay, and this slope is you can find out the slope, no problem with that. So you need to find out what you need to find out. This is in time domain, this is in time domain. So find out the Laplace transform for this signal. Laplace transform आपको निकालना है. So how you do? your approach will be, see, first we need to write the signal in the time domain, mathematical expression. So f of t can be written as, see, this is nothing but r of t signal. R of t, what will be the slope? See, 6 minus 0, 4 minus 2. 6 minus 0 by 4 minus 4 minus 2. So you'll get 6 by 2 is 3. So plus 3 slope is there. Here slope is 0, and here again slope is 0. So you'll get f of t is nothing but 3 r of t minus 2 will be there, and then 0 minus 3, so minus 3 r of t minus 4 will be there, and here uh, minus 6 will come, minus 6 u of t minus 7 will be there, u of, so this signal can be represented by this, and now you can understand that how we can write, see, u of t is Laplace transform is 1 by s, है ना, and see, u of t minus 7 will be, Laplace transform will be 1 by s e to the power minus 7s, obviously. And what will be the Laplace transform of r of t? R of t is nothing but, you know now, r of t is nothing but integration of u of t, है ना, integration of u of t, uh, we can say minus infinite to t, u of t can be written as r of t, and integration of minus infinite to r of t, see, okay, you can write u of t convolution with u of t, because uh, any signal convolved with u of t is similar to integration minus infinite to t u of t. I have told you this property in the first module also. So I can tell you u of t convolution with u of t, it means Laplace transform of u of t is 1 by s multiplied by 1 by s can be also written. So here 1 by s square will come. So r of t Laplace transform will be 1 by s square. So definitely now you can write the f of s directly if you want to write 3 of 3 by s square e to the power minus 2s minus 3 by s square e to the power minus 4s, and minus 6 by s will become e to the power minus 7s. So this is the answer. This is the answer for your question. Very easy. But by this question, you need to understand what, that how to write mathematically this type of expression, and then r of t expression how we'll write. Then this is very easy. Nothing is there in there. Okay. So now we'll see some question related to. See, I'll ask you one question again. How many questions you will practice, then only you can understand the concept. So you have been given a question, f of s is nothing but 1 by s minus 4 square will be there, okay, and s plus 2 will be there, okay, and s minus 1 will be there, okay, fine. And now see, this has been given in your question, and if it is known, okay, you know something, if it is known, some values you know, what you know, that inverse Laplace transform is non-zero right from t is equal to minus infinite to infinite, है ना, its inverse Laplace transform is non-zero for t is equal to minus infinite to infinite. When t is equal to minus infinite to infinite, this inverse Laplace transform will not equal to 0. Okay, it is having some of the other value. Okay, and it is also known that f of s, your f of s is not defined for s is equal to 2 minus j5. आपका f of s is not defined for this 2 minus j5. So this two things you know already, and now f of s is given to you, and you need to find out its inverse Laplace transform. Okay, so let's get started, and we'll try to solve this question. Okay, we'll try. Before my solving, try to pause this video and try to solve this question by yourself, and then you can see the solution. So we'll see. First of all, we'll make ROC, then we can understand its sum of the portion. So we'll make this will be sigma, this will be j omega. Okay. Now we'll see. 1 by s minus 4 square is there. So s is equal to 4 to poles are there, s is equal to 4. Okay, and then s is equal to minus 2, one pole is there, so s is equal to minus 2, one pole will be there, and then s is equal to 1, one more pole is there, s is equal to s is equal to 1, one pole is there. Now we'll see that one ROC can be formed. See, whenever we will take inverse Laplace transform, you know that many inverse Laplace transform can be formed. We need to check its ROC only. So one ROC is possible that all the signals will be the right sided. So this will be ROC1. Okay, ROC1. Let's suppose. One more options is there that all the signal are left sided. So we'll take that this is the possible ROC. So ROC2 will be there. Okay. One possibility is there that this signal is right sided, means for s is equal to 1 and s is equal to for s is equal to 1 the signal is right sided. Okay, the signal is right sided, and for s is equal to 4 the signal is left sided. So like this can be formed. Okay, like this can be formed, and this will be left sided only. Okay, so this can be this value can be ROC3 also. Now one more condition is there that for s is equal to minus 2 the ROC is the right hand sided, and for s is equal to 1, okay, the signal is left hand sided, and then your s is equal to 4 will be right hand sided. So this will be ROC4. ROC4. Okay, so four type of ROC can be formed from this type of expression. Now the condition is, if it is known that inverse Laplace transform is non-zero for t is equal to minus infinite to infinite, it means that if a signal is only not equal to if a signal is equal to 0 for t is equal to minus infinite to 0, it means it is a right hand sided signal. If it is non-zero for or if a signal is 0 for t is equal to 0 to infinite, then it is a left sided signal. But it is not 0 for t is equal to minus infinite to infinite. This condition says that your signal is two sided. Okay, two sided signal. So it means that ROC3 or ROC4 can only happen. ROC3 or ROC4 can only happen for this type of signal. And it has also been said that f of s is not defined for 2 minus j5. So 2 s is equal to 2 is here, minus j5 is here. So s is equal to 2 minus j5. The signal is not defined, so definitely ROC3 will not be there. Definitely this question says that ROC3 cannot happen. So definitely what we are going to see is your ROC number 4. It means that this ROC will be real part of s, है ना? Real part of s will lie from minus 2. It will lie. It will be greater than minus 2. We can say that it will be greater than minus 2, है ना? And less than 1. This is the final ROC for this inverse Laplace transform. So we can write the formula. See, many expressions are there. This look partial fraction, so we'll get a by s minus 4 will come, then b by s minus 4 square, because square term is there, so double it will come, and then c by s plus 2 will come. Okay, and plus d by s minus 1 will come. Okay, fine. And now you can see whatever partial fraction may be, it is not the matter of concern. The matter of concern that a may be whatever value, it will be e to the power minus 4 of t. It will be e to the power minus 4 of t, and what it will be u of t or minus u of minus t. So see, for s minus 2 the ROC is the right hand sided, so obviously it will be u of so see, actually s minus 4 for s equal to 4, the portion will be right hand sided. Okay, so see, no, we need to understand this thing. For s is equal to 4, signal can be right hand side or signal can be left hand side. If right hand side will be there, then again some more ROC will happen. It will make complicated. So better to understand that if it is left hand sided for ROC s is equal to 4, if it is left hand sided, and for s is equal to 1 also left hand sided, so we'll take only s is equal to 1 because it is the smallest pole, and we'll take this, so that will be better choice. So we'll take s is equal to e to the power minus 4 of t will be there. U of minus t will be there, and here minus will come, and same with this. So we'll try b of t will be there minus e to the power minus 4 of t, u of minus t will come. Okay, now see, for c expression is s plus 2 will be there. S plus 2 means s is equal to minus 2. It is in the right hand sided, so we can write c e to the power minus 2 of t, e to the power minus 2 of t, u of t. Okay, and for d s is equal to 1, s is equal to 1 is obviously left hand sided only, so we can write here as d e to the power minus t, u of minus t, and here minus sign will come. So this is the final expression. You can either calculate a and b and c and d value also, and you can put over it. Okay, so see, from this expression you have understood many things. I will try to conclude more thing also. Okay, so see, by seeing the expression, I will ask you some of the question. You should pause the video and you should answer yourself, and then you should listen to the video. So first question will be, if I will ask you now, see, your f of s was given in your question. Okay, according to f of s, these are possible ROC which can be drawn from this, which can be seen, analyzed by seeing the f of s. Okay, so if I will tell you, if inverse Laplace transform f of s, whatever it is given to you, if it is to represent impulse response of a causal system, if I need to represent causal f of s to be a causal system, which ROC should be considered, then you will tell, sir, for causal system all signals should be right hand sided, so this ROC 1 will be considered. That means real part of s should be greater than 4. This is the final ROC. So all ROC is side, only ROC 1 is considered, only s equal to 4 is considered. Okay, now we'll see second type of question I will ask you. Okay, second type of question. If f of s is to represent absolutely integrable, then which ROC should be considered? See, for f of s to be absolutely integrable, it means that it should include the j omega axis, which is possible for ROC number 4 only. So for ROC number 4 only, which it can be possible, that is why I should write that real part of s, okay, should be greater than minus 2 and should be less than 1. This should happen. Okay, now condition 3 will be there. Condition 3 I will write here. Condition 3 will be there. If f of s is to represent a system in which it is defined for s is equal to 3 plus j4, if it is defined, then which ROC should be considered? So see, 3 plus j4 is this one only. So ROC number 3 will be considered. ROC number 3 will have a real part of s will be there. Okay, should be greater than 1, and less than 4. This ROC will be considered. And the fourth condition will be if f of s is to represent a anti-causal system, anti-causal system, then which ROC will be there? So first you will ask me, sir, what is anti-causal system? Then I will tell you, see, you already know what is causal system, what is causal, है ना? What is non-causal also you know. Okay, and you also know that you should know what is anti-causal. Okay, anti-causal is a specific point of non-causal only. See, for causal, what we need, see, causal response, impulse response to be causal, it means that h of t should be equal to 0 for t is less than 0. This condition is represent the causal impulse response. Okay, non-causal is ht is not equal to 0 for t is less than 0. For t is less than 0, ht is not equal to 0. This is the condition for non-causal impulse response. And anti-causal is h of t is equal to 0 for t is greater than 0. Just opposite of causal. जो कॉजल का जस्ट उल्टा होता है वो एंटी कॉजल है, बट नॉन कॉजल इज सी एच ऑफ टी इज नॉट इक्वल टू 0 फॉर टी इज ग्रेट लेस देन 0. मतलब ये इट कैन एग्जिस्ट हियर आल्सो, इट विल एग्जिस्ट ओनली हियर एंड इट विल एग्जिस्ट ओनली हियर. This is the difference between causal, non-causal and anti-causal signal. Okay, impulse response. So now what we are asking, I was asking if f of s is to represent anti-causal system, which ROC should be taken. So you will tell, sir, anti-causal means totally left hand sided, means ROC number 2 will be considered. It means that real part of s, okay, is less than -2. Real part of s will be less than -2 will be there. Okay, and when no condition will be given, if you have given no condition, then definitely this ROC1 will only be considered this causal system. When nothing is there, then you need to understand, you need to take assumption that all systems are causal only, so all response are causal, so you need to take ROC number 1. So see, this is the brief analysis what we were seeing from inverse Laplace transform, and we are seeing this ROC method. See, questions can be asked from like this. One question I'll discuss like this also. See, you need to find the inverse Laplace transform of f of s will be, okay, of f of s is there, and f of s is given in your question ln, okay, s square plus a square will be there, s square plus b square will be there. Now you need to find of inverse Laplace transform. So see, inverse Laplace transform means you need to find f of t will be there. Okay, you need to find. So how you'll do? See, the approach will be, first of all you'll pause the video, you try by yourself, and then you'll see the video. You should see the video. So f of s can be written as ln s square plus a square minus ln s square plus b square. This you can write, log a by b is equal to log a minus log b. Okay, and then see, if you will differentiate df by ds, okay, df by ds, what you will get? You will get 2s by s square plus a square will be there, minus 2s by s square plus b square will be there. So you know df by ds is equivalent to, if you take its inverse Laplace transform, you will get minus t into f of t will come, and all inverse Laplace transform will take 2s will be there. See, 1 by 2 we can do here, 1 by 2, and it will come s by s square plus a square. It means that it is a cos signal. Cos of at we can write 2 into cos of at we can write, and here see, here 2 cos of bt can be written, 2 cos of bt can be written. So f of t can be written as minus 2 by t cos of at minus 2 by t cos of bt. See, simple solution is there, but by seeing this type of expression you should not get fear. The expression is very simple, solution is very simple if you try it. So see, now we'll see some more property we'll see, that is convolution property. Okay, so we'll see convolution property of Laplace transform, Convolution property of Laplace transform says that, if f of t Laplace transform is f of s is there, okay, h of t Laplace transform is h of s will be there. So if we convolve f of t convolution with h of t, and if we take Laplace transform, it is similar to f of s into h of s. This property is similar to that we have seen in the Fourier transform also. exactly the same as Fourier transform. Okay, so um, see whenever we'll see f of t is applied to a system. Let's suppose h of t, its impulse response is h of t, and we'll get output as y of t, which is equal to f of t convolution with h of t will be there. Okay, now this y of s, if we'll form, then we'll get f of s into h of s. Okay, now see what you need to understand. F of s will have many k possible inverse Laplace transform, because it may have so many poles, so many Laplace inverse Laplace transform can be formed. Okay, so if ys is to be considered, है ना, with its ROC, then there will be unique inverse Laplace transform for y of s. Okay, अगर will consider by R, see many ROC can be there, okay, for f of s, but we'll consider y of s with a unique ROC, or its some condition will be there, then y of s can be unique. Otherwise y of s can be also different. So by considering ROC only, y of s can be a unique value. Okay, so we'll see one question. We'll try to understand by one question. One question will be there. um, uh, f of t is given to you e to the power 3t u of t. Okay, and h of t is given e to the power 2t u of t will be there. Now see, you need to find the response. You need to find the response y of t for a LTI system in which input is this and impulse response is this. You need to find the y of t. So we have seen in many type of solution in the module 2 also, how we can solve it by mathematical expression, okay, by graphical expression. Many form ways are there, techniques are there to calculate the output response. One technique is the Laplace convolution property also. So y of t will be equal to f of t convolution with h of t. So here will be y of s will be equal to f of s into h of s. F of s is nothing but 1 by s minus 3 will be there, multiplied by 1 by s minus 2 will be there, and 1 by s minus 3 and 1 by s minus 2, and its ROC 1 by s minus 3, this ROC will be sigma is greater than 3, and this ROC is sigma is greater than 2. So overall sigma will be greater than 3 only. Okay, because both are causal system only. So see, okay, so we can write here like, see, one pole is at s is equal to 3. Okay, one pole is at s is equal to s is equal to 2 and s is equal to 3. So see, number of possible inverse Laplace ROC can be formed at, see, like this, one ROC, second one ROC, and third is in here. Okay, here. So R1, R2, R3. Three ROC can be formed. It means three inverse Laplace transform can be formed. Three inverse Laplace transform can be formed. So see, okay. So if it is a causal system means definitely we'll consider this portion only, and we'll write here like e to the 1 by s minus 3 will be there, 1 by s minus 2 will be there, s cancel, and minus 2 plus 3, so we'll plus minus 2 and minus 3. No, so no, it will take as minus only, s cancel, and minus 2 and plus 3, it will come like this only. So we can write here as, we can write it as e to the power minus 3t u of t minus u of t, because it's a causal. We'll consider causal. If it is not given in question, we'll consider causal only. E to the power minus 2t u of t will be there. This is the final expression for your output of a system. So see, by telling this question, what I need to tell you that one signal f of t was there, it is a causal u of t. You can, if you need to plot its ROC, simple ROC, you can do it. Yeah, h of t simple ROC, you can do it. Now combination will be there, then you have three possible ROCs are there, which we need to consider is, if it is not given in question, we will try to take causal system. So we'll take this ROC and we'll find out this one. So this is very easy, and I think you can understand this. So we'll move on and we'll go with next property. Next property is time differentiation property. We'll try to finish up this Laplace transform in this today's lecture only. We'll not move on with the next lecture. So what is time differentiation property? It means that if f of t is there, its Laplace transform is f of s is there, then if we'll do d of df by dt, means in time domain what we are doing, differentiation we are doing. So what will happen in the frequency domain? It will just multiply s into f of s. This is very important property, and it is used in the differential equations also many times. So this property you need to remember that by differentiating in the time domain, just it is equivalent to multiplication by s in the frequency domain. So okay, we'll try to understand this question by solving one of the this concept by one of the question. Like you need to find the Laplace transform of signal. Okay, of signal is there. Let's suppose e to the power 3t. Okay, f of t is given, e to the power 3t d by dt, d by dt. Okay, d by dt, e to the power t minus 2 will be there, u of 2 t minus 2 will be there. Okay, now see, you need to find the Laplace transform. So first of all, we'll try to find e to the power t u of t will be there. Okay, e to the power t u of t Laplace transform can you find? 1 by s minus 1 will be there. Okay, fine. And then e to the power t minus 2 u t minus 2 will be there. Then what you will get? You will get 1 by s minus 1 will be there, e to the power minus 2s will come. Now okay, now we'll do d by dt of e to the power t minus 2 u t minus 2. It is equivalent to multiplying s with the signal e to the power minus 2 of s will be there. Now it has been asked e to the power 3t into a. So e to the power 3t into d by dt of e to the power t minus 2 will be there, u of t minus 2 will be there. So e to the power 3t, it means that whatever s will be there, it will be s minus 3 will be there. So s minus 4 will be there, e to the power minus 4 of s will be there. Simple question is there. Okay, no, okay, e to the power minus 4s will not come. What will come? E to the power minus 2 and s of minus 3 will come. So e to the power minus 2s plus of 6 will come. Okay, so this is the final answer for your question. Very easy how to calculate. So you can understand that time differentiation property, how we can apply to the questions also. Okay, we can write, I told you, by using this property we can write in differential equation also. So differential for differential equation, how we'll write, I'll tell you. See, if it is given a2 s square is given, a1 s will be there, and a naught will be given, let's suppose. Okay, ys will be given, ys will be given. Okay, and a naught ys will be given. Okay, fine. And here it has been given, let's suppose b1 will be given into s will be given, x of s will be given, plus b naught into b naught into x of s will be given. Okay, this is equation which is overall linear, because no some the constant terms is there, and it is a time invariant system, because there is no multiplication of x into y or something y square, something is not there. So it is a LTI system, and if it is LTI system, we can definitely we can write as y of s, we can take common, a2 s square will be given, a1 s will be given, and a naught will be given. And here b x of s can be taken common, b1 s plus b naught will be there. See, this equation can also be written in the time domain, like a2 s square y of s is given, so d2y by d2 square can also be written, plus a1 sys means dy by dt can be written, and plus here a naught y of t can be written, and here it can be written as b1 d by dt of xt, and means y of t, you can write like this, y of t है ना, and here plus b naught x of t can be written. So these this is the method to write differential equation in time domain, and same as in frequency domain, and then we can just solve it as, if you need impulse response, you just need to solve b1s plus b naught by a2s square plus a1s plus a naught है ना. This is the expression, we'll get it. Okay, so we'll move on with our next property. Next property is time integration property. So we'll write as time integration property. Time integration property. Okay, so time integration property says that we will do integration in the time domain. If f of t Laplace transform is f of s is there, then if we'll integrate minus infinite to t, f of t dt will be there. Then what will happen? What will happen that this is same as that of f of t convolution with u of t, and you can see the Laplace transform f of t convolution is f of s. F of s will be there. F of s will be there, and u of t Laplace transform is 1 by s, and convolution means multiplication the frequency domain. So f of by s. So ultimately, what you get formula is integration. Whenever we integrate in the time domain, it is similar to multiplying 1 by s in the frequency domain, just similar to that. So see, we'll see some question, and we'll try to understand that. See, first of all, what you need to understand by this property, see, minus infinite to t from anywhere. So earlier, actually, what we were taking, our Laplace transform is bilateral Laplace transform, bilateral, and there is one more variation of Laplace transform, that is unilateral Laplace transform. What it means, see, bilateral Laplace transform is whenever we'll consider f of s will be minus infinite to infinite f of t e to the power minus st dt. This is bilateral Laplace transform. But if we'll consider f of s will be equal to times 0 to infinite, and then we'll consider f of t into e to the minus s of t dt, then this is the unilateral Laplace transform will be there. So there are many variations in the Laplace transform by seeing both conditions. I will explain you. See, a signal is there, u of t is there, okay. U of t is signal exists from t is greater than 0. T is from t is greater than 0, the signal exists and it will go on, and it does not exist for t is equal to t is less than 0. This is there. So why we need to calculate from minus infinite to infinite? If we will calculate from minus infinite to infinite, what the value will get? U of t will be 1 by s for convergence sigma is greater than 0. This is the value we will get. Okay. Okay, fine. And see, now you tell me, minus u of minus t Laplace transform will be 1 by s only for sigma is less than 0. This we have studied earlier. Okay, understood. Now you tell me, for bilateral transform we have seen that u of t is 1 by Laplace transform is 1 by s for sigma is greater than 0, minus u of minus t Laplace transform is 1 by s for sigma is less than 0. But for unilateral Laplace transform, we are considering only from 0 to infinite. So how come this value will be for sigma is less than 0? So this value Laplace transform cannot be calculated for unilateral Laplace transform. This you need to understand. Okay. So now see, now you can see that u of t was having the same expression 1 by s, and minus u of minus t was also having the same expression in the bilateral Laplace transform. Only they were differentiated by sigma is equal to for sigma value, for ROC value only they were differentiated. But in unilateral Laplace transform, this value doesn't exist only. So there is no question of the same expression, because this value is not exist, only one value is there. So for unilateral Laplace transform, ROC value is not at all required. Simple concept. For unilateral Laplace transform, ROC is not required, because expression is by itself same, by itself unique. I can say unique. It is unique, and no other expression can have in the unilateral Laplace transform. I'll tell you one more example, then you can understand it. See, I told you to calculate, find the Laplace transform. Find the Laplace transform of first f of t is equal to 1. Let's suppose this is equal to 1. I told you Laplace f of t is equal to 1 can be written as u of t plus u of minus t, है ना? In bilateral Laplace transform, it can be written as, because u of minus t will exist in bilateral, na? No problem is there. So it will happen, this Laplace transform will be 1 by s minus 1 by s, so it will value 0. So in bilateral Laplace transform, f of t is equal to 1. Laplace transform is not defined, but for unilateral Laplace transform, f of t is equal to 1 will be equal to only u of t, because u of minus t will not exist. So here only 1 by s will come. So ultimately f of t is equal to 1, Laplace transform will be 1 for unilateral Laplace transform. Okay, and now I'll tell you second part. Let's suppose e to the power minus a mod t is there. Okay, its Laplace transform was nothing but e to the power a minus at u of t will be there, plus e to the power a t will be there, u of minus t will be there, है ना? And it will come as 1 by s minus a will be there, plus 1 by uh, 1 by s 1 by s plus a will be there, and 1 by s minus a will be there, but minus sign will come here, minus sign. This we have seen earlier, and then we have calculated its value also. S and s will cancel, so here minus a minus 2a by s square minus a square will be there. In a mod t bilateral Laplace transform value will be this much, but for unilateral Laplace transform, Laplace transform, e to the power mod of t will be equal to e to the power minus at u of t only, because u of minus t value will not exist, because in unilateral only we are considering from 0 to infinite. So this value will be 1 by s plus a value only. So see, you can understand that here no ROC is required, because no two expression can be same. For unilateral Laplace transform, but in bilateral Laplace transform, two expression can be same. That is why their ROC is specifically required. So in question, if you have been asked to find the Laplace transform or something, ROC is given or some condition is given, then it is a bilateral, but nothing is given, and then you can go for unilateral Laplace transform, and we need not to consider the ROC value. So see, now you can understand that we have seen the time differentiation, time integration property. We'll also see time differentiation property. Okay, time differentiation property, I think we have seen just I think we have not seen. Okay, we'll see time differentiation property. Time differentiation property. Time differentiation property says that if f of t is there, its Laplace transform is f of s, then if will d by dt of f of t will be there, then it is s into fs. I think we have seen just now only, we have seen time differentiation, this only, just okay, no problem. You have seen the time differentiation property. Okay, fine. So why we are seeing here in time differentiation property, this expression is valid for bilateral Laplace transform. This expression is valid for bilateral Laplace transform, but for unilateral Laplace transform, for unilateral Laplace transform, it is the value is exists for greater than t is greater than 0. So there may be some previous value also which we need to consider. Okay, so in unilateral Laplace transform, d by dt of f of t, okay, will lead to s of fs will be there, but some old value will be there, initial value will be there. So this you need to understand, because see, this we can see in the control systems also. Many times this usage will come, like see, when you will see inductor, okay, and when you will see capacitor, and we'll see, inductor will store energy in the form of magnetic field, okay, and capacitor will store energy in the form of electric field. So we'll see, I is equal to, for capacitor, I is equal to c dv by dt will be there. This is capacitor current, है ना? So c dv by dt is there, c is there, dv by dt can be written in Laplace, can be written as s into v of s will be there. S into V of S minus, V of S means actually it is a voltage capacitor, so VC we can write, and some initial value will be there, VC 0 minus will be there. So IC we can write IC of S can be written as like this, means capacitor current in the S domain can be written like this. Similarly, see, as you know that voltage across inductor will be L di by dt, and I will be inductor current, है ना? So VLS, if you can write voltage across inductor in the S domain, you can write L S into I of LS can be written, okay, minus initial value IL 0 minus can be written. So like this, where here we are taking initial in that unilateral Laplace transform, and we are taking the initial values also, okay. So if you have understood this property, now the last property which will deal with Laplace transform, and we'll close this module, and from next module we'll go for Z transform. So last theorem we need to see is initial and final value theorem, initial and final value theorem, and this will same, all the properties will be similar in Z transform also. So we'll see in the Z transform also initial and final value theorem, initial and final value theorem. What does it mean? Initial and final value theorem simply says that we need to calculate the initial value in time domain and final value in the time domain. We are calculating initial and final value in the time domain, okay. So see, for initial value we can understand that, see, f of t, Laplace transform is f of s, okay. If we need to calculate initial value, we need or we can write C, we can write like this, okay. We will write initial value means f of 0 will be there, okay. F of 0 can be calculated as limit of s tending to infinite, s tending to infinite, s of f of s, okay. So this is the condition for initial value, this is the condition for initial value, limit s tending to infinite, s of f of s will be there, okay. First of all, you need to understand which for which conditions this value, this formula can be satisfied. So first condition is, the first condition is initial value theorem, initial value theorem can be applied for, can be applied, can be applied for only if, can be applied only if your f of s is given ना, जब आपका f of s is given, f of s, okay, its degree of numerator is less than degree of denominator. This condition you should remember, this condition you should remember कि f of s is given for you, f of s degree of numerator will be less than degree of denominator, then only this initial value theorem can be applied. Otherwise you cannot apply initial value theorem for finding initial values like that of, see, f of s is given, let's suppose s plus 5 by s square plus 3s plus 2, okay. One f of s is given, let's suppose f of s is given s square plus 2s plus 3 s square plus 3s plus 2, and f of s is given f of s cube plus 2s square plus s plus 3 will be there, and this will be s square plus 3 s plus 2 will be there. Now you can understand, see, I have given you three expression. This expression, uh, uh, your numerator, degree of numerator is less than degree of denominator. So here we can write, let's suppose a s plus 2 will be there, plus b s plus 1 will be there. Okay, so its value will be a e to the power minus 2t u of t, let's suppose, and b e to the power minus t u of t. Definitely a, in time domain, if you'll see, for t tending to infinite, for t tending to infinite, or t tending to 0, you can see some value will be defined. So f of 0 will be defined value. Okay, for f of 0 will be defined value for this. But for this expression, see, both are similar, both are same degree of numerator is equal to denominator. So we'll get some constant term like c s plus d, let's suppose. You'll get s square plus 3s plus 2. Okay, so if you take its Laplace inverse Laplace transform, in time domain, you'll get delta t will be there, plus something value will be there, a1, let's suppose, e to the power minus 3t u of t, plus b1 e to the power minus t u of t will be there, something will be there. But see here, for time t is equal to 0, for time t is equal to 0, will not get defined value. F of 0 is not defined for t is equal to 0, because as you know that delta t at t is equal to 0 is not defined value. It is not equal to 0, but you cannot calculate what value is there. So this f of 0, we can write, is not defined. F of 0 is not defined. Okay, now for this value we'll see, this expression is degree of numerator is greater than degree of denominator. So here some more value will come, s plus, let's suppose, k will come, and then we'll get c1s plus d will come, c1s plus d1, let's suppose, and s square plus 3s plus 2 will be there, and it will have some values like delta dash t will be there, and then derivative of k into delta t will be there, and then you'll get some value, let's suppose a2 e to the power minus 3t u of t will be there, and let's suppose b will be there, b2 e to the power minus 3 e to the power minus t u of t will be there. So here also some expressions, see, whenever both degrees are similar, you'll get some impulse function, and that is why your initial value is not defined. That is why your initial value is not defined, because you cannot put delta 0, and you don't know delta 0 value, so it is not defined. And for this type of signal, again your delta t will come and delta dash t will come, and here also same value, if you, for f of 0, value will be not defined. So that is why, for that, this is the reason behind this thing, that initial value theorem is not applied for uh, f of s is not applied for, your condition is not applied for when f of the degree is greater than or equal to degree of denominator. It should be applied for degree of numerator is less than degree of denominator. And why it is there, I have told you by 3 examples. Okay, now we'll see final value theorem. This was initial value theorem. Now you can understand what is initial value theorem. Now we'll understand final value theorem. Final value theorem. Final value theorem suggests that if we need f of infinite value, if you need, it is similar to limit s tending to infinite. Now earlier what we have done, see, initial value also we have seen s tending to infinite value will be there. Here s is not tending to infinite, sorry, just opposite will be there, s tending to 0 will be there. This is, you should remember, for initial value we are taking s tending to infinite, and for final value we are taking s tending to 0, this only. And again you will be s into fs will be there. Okay, in both expression, what is different is only s tending to what value will be there. This is the final value theorem is there. Okay, So we'll see some example, like see, there are conditions, because I told you there also in initial value there are some conditions in which initial value theorem can be applied. The same like this, some condition will be there for final value theorem also. So first we will see, let's suppose f of s is there, and this is 1 by f of s is 1 by s. So what will be the Laplace inverse Laplace transform? F of t will be, obviously it is u of t, है ना? U of t. U of t, what is u of t? U of t is like this. Its value is going on, going on, going on. So can you calculate final value? So u of infinite value will be taken, and u of infinite is always 1 only, because this value is 1, similar, go on, go on, going on, going on. So it is 1. It is defined. Okay, fine. It is defined value. Now again we'll take some another question. We'll see f of s will be there. F of s will be there. It is 1 by s plus 4, let's suppose. Now f of t, what will be happen? F of t will be there, so it will be e to the power minus 4t u of t, e to the power minus 4t u of t. If I ask you f of infinite value, what will be there? See, e to the power minus infinite value, u of infinite, so it will be around 0 only. So it is properly defined, so I can tell you that it is properly defined value for final value theorem. Okay, fine. This is also good. Okay, fine. If I'll tell you that find f of s is equal to 1 by s into s plus 4. Now if you will calculate f of t will be, then how you will see, f of t is nothing but 1 by s minus 1 by s plus 4 will be there. Okay, well, and okay, for easiness we will do one, will do one, then nothing will happen. Okay, so here it will happen, 1 will be there, f of t will be there, sorry, this was f of s only. F of t will be 1 minus e to the power minus t u of t will be there. Okay, so okay, and if you will tell f of infinite value will be 1 minus e to the power minus infinite u of infinite, it will be 1 value. So it is also defined. So okay, this is also very good. Now I will ask you, now you should understand what I was about to tell you. F of s is equal to 1 by s square will be there. Now you find f of t. So f of t will be f of t will be your r of t, or can be written as t into u of t will be there. T of u of t will be this only. Now if I'll tell you f of infinite value, please tell me. Then you'll tell, so infinite into u of infinite will be infinite. Is it defined value? Not defined. It is not defined. Okay. Now you'll understand. Now you'll understand what I was about to. This final value is not able to understand. So if I'll tell you s minus 4 will be there. So now if I'll tell you f of s, f of s is 1 by 1 by s minus 4. F of t will be e to the power e to the power 4t into u of t, e to the power 4t into u of t will be there. Okay, so f of infinite value, what will be there? So e to the power 4 into infinite u of infinite, so the value will be infinite value only. So it is defined? So it is not defined. This value is also not defined. Now I'll tell you uh, if f of s is given, f of s given, let's suppose omega naught by s square plus omega naught square will be given. Okay, its f of t will be, if f of t will be sine of omega naught t u of t. So if I'll ask you f of infinite value, then what you will tell? Sir, it is indeterminable, because see, the sine omega naught t may be plus 1, maybe plus 1, maybe minus 1 for t is equal to infinite value. So we can tell that it is indeterminable. It is indeterminable. Okay, okay. So see, I have told you many questions, and I told you this is defined, this is defined. For defined value nothing problem was there, but for not defined, how will calculate the final value? So see, f of s is equal to 1 by s square was there, its value was not defined. So if we can multiply s into f of s, then what will happen? S into 1 by s square will be there, so the value will be 1 by s only, है ना? Or see, so s into s fs, this value was there, okay, so its pole will be at s is equal to 0, है ना? S is equal to 0, or in the j omega axis, the pole will lie in the j omega axis. See, uh, uh, f of uh, s into f of s will be s into 1 by s minus 4 will be there. So here what will be there? Its pole will be at s is equal to 4, s is equal to 4, and 1 0 will be there, okay, no problem. So here the pole is in the right hand side, so here see, this for 1 by s square, final value theorem was applied. Final value theorem means final value was able, either we was able to calculate final value theorem, so we were not able to calculate, है ना? We were not able to calculate its final value, uh, and we are now analyzing why we are not able to calculate, why the value was undefined. So see, its final it's when we are multiplying s with this signal, and we are seeing the poles value, what we are getting, that pole is in the j omega axis. We are seeing for 1 by s minus 4, what we are getting, the poles is in the right hand side. Let's suppose that s into your omega naught by s square plus omega naught square, okay. So here where we are getting plus minus j omega naught, we are getting the poles, okay. So see what, ultimately these three values sine omega naught t, okay, these three values, your final value theorem, final value you are not able to calculate. But for, let's suppose, these three value, 1 by s was there, 1 by, for 1 by s signal, let's suppose I will write with blue pen, 1 by s signal, if you do s into f of s, what you will get? S into 1 by s, you will get cancel out, so no poles will be there, so the value is defined. For this value, s into f of s will do, so we'll get s by s plus 4 will get, and we'll see the pole, it is in the minus 4, है ना? So it is in the left hand sided. If we'll see 1 by s plus by 1 by s into s plus 1, so we'll see s into f of s, will get 1 by s into s plus 1 multiply, and multiplied s also, so s cancel out, so 1 by s plus 1 will be there, and its pole will be in the left hand side. So now what I wanted to tell you, now maybe you are getting, you are now understanding it, that if your pole is not there, if your pole is in the left hand sided, and here also it is in the left hand sided, all final values were defined, है ना? All final values were defined, but for the value when s into f of s we are doing, and we are getting the poles at j omega axis or in the right hand side, so then that value is not defined, है ना? That value is not defined. So final conclusion what we can draw from here, that condition for applying, final value theorem is that, condition for applying final value theorem is that, that poles of s into f of s, okay, I will write here poles of s into f of s, because see, in the our formula also we are doing s into f of s. I am not telling only poles of f of s, I am telling you the poles of s into f of s, when poles of s into f of s should be in the left hand side of s plane. This is the first and foremost condition for applying final value theorem. Final value theorem can be applied if I can tell you all poles, this all poles of s into f of s should lie in the left hand side of s plane, if poles lie, अगर if poles lie या फिर I will write poles of s into f of s lie on j omega axis, अगर वो j omega axis में lie करते हैं, है ना, okay, j omega x, if it is lying on the j omega axis or in the right hand side of s plane, right hand side of s plane, then तब क्या होगा, will write here, then final value of f of t, final value of f of t is either undefined, either it is undefined or indeterminable, okay, indeterminable, in which case f of final value theorem must not be applied. Okay, I will write here, in which case final value theorem should not be applied, should not be, या should की जगह cannot लिख देता हूँ, cannot be applied, है ना. So this is actually final value theorem, and this leads to the end of Laplace transform. This was the final thing which I need to tell you from Laplace transform, and this brings to closure of Laplace transform. We'll in the next lecture we'll start our Z transform. Okay, we'll start Z transform, and we'll see what is similarity between Laplace and Z transform, because from starting only I told you it is just similar to Laplace transform, just it is doing in the time domain, that will be done in the this is done in the continuous time domain, that will be done in the discrete time domain. Okay, so we'll see in the next lecture, and if you have liked, if you have understood from this video, if you have gained some knowledge from this video, so do hit the like button, comment in the comment box. Your valuable feedback is very much required for us, because we are taking out our time, effort, and we are recording our lectures free of cost. No money will be gained from these video lectures. It is just for the benefit of students. So share with needy students as much as possible. This is our request from our side to you, that just your work is there, that you should gain knowledge from this video and share with as much as students as much as possible, because it will help to those, if it is helping to you, actually if it is helping to you, so it may help to others also. So and if you have not subscribed to the channel, do subscribe it, so that you will get the latest notification as soon as possible. So we'll close up today's lecture, and we'll see in the next lecture, will module 6. Till then, tata, bye bye, see you, signing off from today. So Jai Hind, Jai Bharat.